One of the common areas where we use proportions is when we know all of the information about one shape, but we don't have enough information for a similar shape that is just a different size, but still the same exact shape. So if we think about this, we are going to have, for example, a triangle. We'll name this one ABC. And then we have another triangle, and this one we're going to name X, Y, Z. And we say that ABC is similar to X, Y, Z. So that means that they have the same proportions, and that means if I know certain information about one of them, I can find the same information about the other one. So it's important that we know two of the pieces of information. The other thing that's important is we have to recognize which sides are going to be related. So here we can see that side AC is similar to side XZ, and side AB is similar to side XY. And lastly, BC matches with YZ. So it's important that we're recognizing which sides are in the same position on that shape. So if I said that this side was 3 and this side was 5, and then we'll say that this side is 8. And I just made these numbers up, so they aren't necessarily going to create a triangle that looks just like this. And let's say that I know that this side is 10. Then what that means is that I can find out any of the other two sides because I know the two shapes are proportional. So let's see if we can figure out what the side XZ is and what the side XY is. So just like we talked about in learning how to deal with proportions, that means that I have to make sure that these are set up the same. So the one piece of information that I do know is the green side of the triangles. So the very first proportion I'm going to write is that side. So we've got 3/10. It's important when we write these proportions that we keep the same triangle at the same level. So in this case, my smaller triangle side is on top and my bigger triangle side is on the bottom. And when I set up my other proportion, it needs to be the same. So we're going to do the yellow side. So on the small triangle, the yellow side has a value of 8. And on the large triangle, that is the value that we don't know. So we're just going to go ahead and put an X in there. Then we're going to go ahead and do our cross multiply. So I have 10 times 8 gives me 80. And then I have 3 times X gives me 3X. Now, oftentimes you're going to find that your answers are going to be decimals or fractions. And so it's okay to just leave them in decimal or fraction form. So now I'm going to go ahead and divide both sides by that 3. And when I do that, I find that the side is equal to 26.6 repeating, or 26 2/3. So I know that the yellow side on the larger triangle is going to have a value of 26 2/3. Then I would go ahead and repeat the process with the red side. All right, so for the red side of the triangle, then we know that so we want to start with the side that we know. So we're going to have that 3/10 again. And then we know that the length of the red side on the small triangle is 5. So that's going to go on top. And then the length of the big triangle on the red side is the thing that we don't know. So now we're going to go ahead and do our cross multiply. So we have 5 times 10 equals 50. And 3 times X equals 3X. And now I'm going to go ahead and divide by 3. And when I calculate that, I get 16.6 repeating, or 16 2/3. And so now I know the lengths of all of my sides of my triangle. If I go ahead and plug any of them in and do the calculations, then I would have the same number equals the same number. What's important to note is that if you do round the value, so if you said 16.6 or 16.7, then when you use that, then they're not going to be perfectly exact because you're using a rounded value. If you use the fraction, then you would have the exact answer. The second way that we see two shapes that are the same is when they're actually the same shape, but then it's been split. So we know that they're going to have the same shape. And so let's say that we know this smaller triangle and we need to use it to find a larger triangle. So oftentimes this will be used when we know a shorter object, and then if you look at it and create a bigger triangle, then you can do that because the small triangle will be proportional to the bigger triangle. So in that case, this yellow side here would be equivalent to that yellow side. This red side here would be equivalent to that side. And this green side here would be equivalent to that side. So you can see how these are a lot easier to see which sides match up, and we don't necessarily need the names of the corners. So if I did a triangle, so if we make this 2, we make that 5, and we make that 10. Maybe now I can get nicer numbers this time. And then let's say that we know that this longer distance is going to be 20. So now I can go ahead and create my fractions. And so the two sides that I know for both triangles are 5 over 20. And let's say that I'm trying to figure out the height of something. So in my smaller triangle, the height would be 2. In my bigger triangle, the height would be x, because that's the things I don't know. So in this case, we are going to go ahead and we're going to do our cross multiply. So 2 times 20 gives me 40. And then 5 times x gives me 5x. And now I can go ahead and divide both things by 5, and I find that x equals 8. So the height of this larger triangle would be 8. And then if I also wanted to find the length of the diagonal, I could do the same thing. But this is a second way that we show similar shapes. So this one is when we split it in half to make a smaller shape that looks exactly the same within the larger shape.